that's just equal to 1. Anything to the power of 0 is equal to 1. All right, so in this example 3, we're going to find the equation of the inverse of f of x equals 2 to the power of x. So how do we find the inverse? Remember the steps? We swap first we write y equals 2 to the power of x. Then we swap our x and y values. So x is equal to 2 to the power of y. Now, we need to isolate for y, but our y value is in the exponent. And we just learned a technique to deal with that, and that is to take the log of both sides. So I take log x is equal to log 2y, 2 to the power of y. And remember, anything that's an exponent can be written in front of that log. So log 2 to the power of y becomes y log 2, and you just divide both sides by log 2 in this case. And y is equal to log x over log 2. They also did this, which is an extra step. You can leave it like this, because log 2 is just a number, and you could just figure it out this way. But this is very important, and this is called the change of base formula. And I'm going to explain to you why this is super important. In your calculator, when you see that log button, your natural log is base 10. Meaning the calculator button in your calculator is always going to be log base 10. You're not going to have log base 3, log base 2, log base 5, or whatever. It's always log base 10. I'm going a little bit ahead of myself because I haven't explained the bases yet to you. But essentially, what you need to know is that the calculator button in your calculator is always log base 10. And sometimes the question will have log base 2, or log base 3, or log base 5. And you can't just punch that into your calculator. You need to do something called the change of base formula and change the base into log base 10 for you to be able to solve it. And I'm going to go into examples for that. I'm going like way super ahead. This is like lesson 2, 3. But just something that you should know. And this formula, you need to write this down right now. Write it down. Okay, good. Because this is very, very important. So this is what happens. Y equals log base 2x. And so the inverse function of y of f of x equals 2 to the power of x, it's just f of, the inverse x is equal to log base 2x. I'll give you a hint. When it comes to inverse functions, the base values, the numerical value for your base is always the same. So my b value is 2, but it's an exponential function, so it's 2 to the power of x. And for my log, my b value is also 2. My base value is also 2, but it's log because it's inverse. Okay, so now we're going to compare the graphs of f of x and f of inverse x. So f of x with 2 to the power of x, you have your 5, t points, -2, -1, 0, 1, 2. You have your y values, 2 to the power of -2, which is 1 over 4, 2 to the power of -1, which is a half, then 1, 2, 4. It's, if you haven't seen the pattern, it's multiplying by 2. Yes, sir. And then for log base 2, all you have to do is reverse the x and y values. That's it. There's no, you don't need to figure out any patterns, just reverse x and y. So now instead of -2 being in the x value, it's in the y value. If you plot these points, so -2 and a quarter, it's going to be here, -1 and a half, it's going to be here, 0 and 1, 1 and 2, and 2 and 4. And then if you plot the other values, so x is a quarter, and -2, so probably something like this, then x is a half, -1, then x is 1 and 0, 2 and 1, and then 4 and 2. So you can see that the graphs are like this, right? When it comes to inverse functions, yes. No, when it comes to inverse functions, it's always y equals x. That's the definition of an inverse function. And here's some relations when it comes to intercept. So for x-intercept y equals to the x, you can clearly see that there is no x-intercept because there's a horizontal asymptote, so no x-intercept. Y-intercept is 0, 1. Domain is XCR, meaning this function in blue that's at the top goes all the way to the left, all the way to the right. So XCR. The range, however, is restricted. It's y greater than 0. See how the whole graph or function is above the x-axis? And then there's the horizontal asymptote. Perfect. For the inverse function, it's flipped. So since there was no x-intercept for my initial function, then the inverse function has an x-intercept that was your y-intercept. So instead of 0, 1 being here, it's 1, 0 here. Because it's swapped. The 0 and 1 and the 1, 0, right? but there's no y-intercept because the x-intercept and y-intercept are swapped. Domain and range are swapped as well. So in the initial function, domain was xer. Now in the inverse function, range is yer. See that? And then now the range is yer, y greater than 0. The domain now is xer, x greater than 0. So when it comes to these properties, they're very simple. They're just kind of the flipped reverse of the initial function. So as long as you can graph your initial function and do all this for your initial function, the inverse is just flipping the x and y's. And then now, the initial function has an horizontal asymptote. The inverse function has a vertical asymptote. That's it. Which you can see, it's right here, vertically. All right, any questions? All right, so practice examples. See if you can rewrite each in logarithmic form. So log form is this form here. You know what? Let me do one example. Sorry. Let me do one example. This is a little bit confusing. The way to do it is to take the log of both sides, but this is where I didn't teach you the base value yet. So just like exponential functions, logarithms have a base number or base value. That affects, the numbers. There's a property, which we haven't gone over yet, which I'm going to teach you right now, is if you take the log of base 2, and let's say your number is also 2. Say the base number is equal to the number that's it's being applied to. That just equals 1. It's kind of like multiplying by 2 and dividing by 2. You get it? Because if you take something, you times it by 2 and divide it by 2, you're basically you're not changing it, right? So it's just like that. So if I take the log base 2 of 2, that's basically 1. So it just cancels out. It just goes away. So the way to do this specific question, or these specific questions, is to take the log of your base value. Now, what is my base value in this first equation here? 2. Yeah, exactly. The base value is 2. So I'm going to take log base 2 of both sides, like this. You see what I did there? And now I know the rule that whenever I have an exponent, I can just bring that to the front, right? So this becomes log base 216 is equal to 4 log base 2, 2. And now you see how this right here, this cancels out? Because log base 2 of 2, right? So this cancels out, that's just 1, so just, it's 4 times 1. So the answer is log base 2 of 16 is equal to 4. That's the answer. So that's how you change it from a exponential form to a logarithmic form. Do you want me to do one more example? Okay, sure. Here, what's my base value here? Yeah, exactly. N, because that's the base value. That's the thing that has an exponent. So I'm going to take log base n to both sides. And remember, whenever you have an exponent inside the log, you can just take it out and write it in front. And hopefully you can see now what's going to happen. It's going to be 3 log base n, n. And the reason we purposely choose log base n is because we want this part to cancel out. So the answer just becomes, exactly. There you go, that's how you do it. Can you do this one? Yeah, we're not really, this is just practice to get you into the habit of doing this. We're not actually solving anything right now. This is just very basic, elementary, one-step things. When we get to more advanced questions, then we'll be using this to help us solve other things. So go ahead and do example C. So now the negative 2 goes out in front. So it's going to be negative 2 log base 3